All right, so this sheet is front and back. It is basically a different version of notes and a different way of explaining the PowerPoint notes that are on the other lecture. I'm not going to go through this in a ton of detail. Basically what I'm going to tell you, this is from a specific book that I pulled this from that explains on one side in words. Okay, in this case, there's the diffusion explanation. Here's a nice picture with a before and an after, okay, of what happens if oxygen diffuses through the membrane of a cell. Then it goes through on this same side of the piece of paper, a generalized explanation of osmosis, explanation on the front, on the left, and then a generalized diagram on the right, okay, of what might happen. Then you have a situation with a cell in an isotonic solution. Now, what I do want to point out on this one, so here's your description on the right and your picture on the left, okay? Here we've got equal concentrations of some sort of solute, okay, and they're giving you percentages. So what you have to imagine is that there's 4 solute particles here on the inside and 4 solute particles here on the outside. And so just imagine those within, water on either side of the membrane to give you equal concentrations. Notice that water is moving in and out because the cell is already at equilibrium, right? Read that. And then from there, notice that with the hypotonic solution, in that situation, notice that inside the membrane, you've got a 30% solution, and outside the membrane on the diagram, so in the environment, you've got a 10% solution. So again, those dots are your solute, and then just imagine that there's no water. So this just looks different than what you had on your, or in your PowerPoint notes, okay? So notice water is going to move into the cell is going to get larger, pressure inside the cell is going to increase as well, okay? And in theory, the pressure could increase to the point that the cell bursts or lyses open. Okay, then on this one, you've got a cell in a hypertonic solution as the last example of osmosis. Description on the right, picture on the left. This time, notice you've got a 10% solution inside the cell, 30% outside the cell. So water is going to leave, the cell is going to get smaller, the pressure inside the cell decreases as well, okay? Make sure that you read over all of those about osmosis, compare them to the PowerPoint notes, right, so that you've got 2 different explanations, because the PowerPoint notes in my lecture, you would have to listen to several different times. I would maybe make some notes on your PowerPoint notes or connect some things in some different ways to make these make sense and that these are telling you the same thing. Okay, then you have active transport. So it gives you a definition, an explanation on the left, picture on the right. Sorry about my phone, I didn't turn the volume back down. Then you've got an example of endocytosis in general, okay? And then you have an example underneath that of exocytosis that's very general as well, with a nice, pretty simplistic diagram. Okay, so there's endocytosis, and then there's exocytosis. And then again, I'm just not going to explain these in too much detail. Okay, so make sure that you read over those. This is an additional set of notes. Let me know if you have questions.